Good afternoon. My name is Matthew D'Antuono, and this is my Engineering 430 project number 3, which deals with economic lot sizing. So my goal with this project was to build a decision support system that enabled the user to build a production plan by solving the economic lot sizing problem. Basically, based on different variables such as demand, production costs, and other costs, I wanted to use linear programming to solve the economic lot sizing problem. Just to tell you a little bit more about the variables, we had variables that were input by the user, such as production cost, inventory holding cost, setup cost, and demand, each of which the user got to choose based on their real world problem, what those values were. And then we had values such as amount produced, inventory level, and does production occur, which was just a yes or a no, 1 or a 0, that were changed by the linear program in order to come to an optimal solution. So you can see right here to the right the linear programming model, which uses all of these variables in order to come to an optimal solution of the minimum cost at the end. So the reason behind choosing this topic was my interest in material requirements planning, or MRP, and I think that mainly stems from my work in construction, knowing that I never want to run out of materials and I never want to be behind. Also, my project 2 dealt with MRP, and this goes hand in hand with it. It's just another step. So my itemized specifications for this project were user form usage, which just meant to use VBA and user form in order to make a pretty user-friendly experience for whoever's using the system. 2 methods of solving, which were linear programming or dynamic programming. The system wanted me to use both. A graphical representation of solution. More specifically, it called for a sensitivity analysis of the results. It also wanted a way to enter data manually and import data. So you had 2 ways for the user to get their production data into the system. And finally, just to report my findings, which was the optimal cost and even give access to the production plan at the end. So right now I'm going to go ahead and I'm going to pull up my economic lot sizing workbook. You can see here that we're on manual data entry sheet. You can see that we have weeks, which is just the amount of weeks. It'll go across here, however many you want to go to, up to 20. And then however many weeks you have, you enter your demand for each one of those weeks. And then right here, you go ahead in each one of these 3 cells and you put in your unit production cost, inventory holding cost, and setup cost respectively. So if I go ahead and hit start over, like I've already done something, it'll bring this screen up, which is actually what comes up when you open the program itself. So when I hit begin, it'll give me 2 options: select a data file or enter data manually. So I'm going to go ahead and do this one first just to show you guys what it does. So when you choose to enter data manually, it tells you to give the length of the planning horizon T, and this is in weeks. So like I said before, it can only go up to 20 weeks, so say I put 23 in here. See what happens. Time period cannot exceed 20 weeks. Alright, I get to 9 and it brings me back to here. So we'll go ahead and we'll say 9 weeks. Continue. So it gives me weeks 1 through 9. I can go ahead and I can say this is my demand, this is my demand, this is my demand, all the way through. Same thing down here. You can go ahead and put in your cost, your unit cost, production, unit inventory, holding, which would probably be more something like this, and your setup, whatever that may be. So that's how you do the manual data entry. So if I go ahead and hit clear, I can get a fresh slate. The other way is to import data from another file, which I'm going to go ahead and show. It's called ELS test. And what this is it's formatted exactly like the other one, but what that gives me the ability to do is give this file to somebody who wants to fill out their data beforehand, and they can fill it out in the same format, and then when they want to use the economic lot sizing workbook, it'll import their data straight in and be able to use it like it is. As you can see up here, there's a disclaimer that says data must remain in this format in order to be imported properly. Alright, I'm going to close that down. I go ahead and hit start over. We'll go to begin. Okay. So we've already done enter data manually. Now we're going to go ahead and select data file. Continue. then it prompts you for the data file name, which we just saw, is ELS test. So when you hit go, it brings the data in. The ELS test file has up to 6 weeks with each one of these different values, and then these respective costs. So now you have those in there, you're ready to send it to the formula page. So we'll hit continue. You can see right now that all the optimal costs say 0. We'll go ahead and hit Excel Solver Solution. And it says Solver found a solution. All constraints and optimality conditions are satisfied. So go ahead and hit OK. And it shows us right here what the optimal costs are for each one of these. So now we can go ahead and click this button to go to the production plan in order to show us what exactly we have. So up here we have the variables that we had, our unit production costs, unit holding costs, and setup costs. And what those do is they come from the manual data entry page. They come into here and then they're used to calculate all the other costs. For example, the unit production cost is, or the full production cost is the unit production cost times the amount that you produce. And so you can see up here that that formula gives us. So in order to run the linear program, we had to set out our constraints down here. So this is what my constraint looks like. Q of t plus I of t equals B of t plus I of t. So you can see I use the formula to pull from their respective areas in order to make these calculations. And same thing over here. So you have entered 6 weeks, and so your production plan would be up to week 6 right here. So you can see down here again we have our optimums. And what you can do from here is you can either start over, which takes you back here, clears everything, gets you ready to begin, or you can also exit the program, yes or no. We're going to skip that for a second so I can go ahead and show the solver. So in order to solve the linear programming, I used the Excel solver with my objective function as my total cost, because that's what I wanted to know based on many other constraints in here. So now that I've showed you all that, we'll go ahead and exit the program. Alright, so specification comparison based on the specifications that they wanted and what I was able to do. User form usage. Yes, I used many user forms in order to help us get through, whether it was the welcome user form or the data entry user form. Two method solving I was unable to complete. I was only able to use linear programming due to lack of time. Graphical representation of the solution. Another problem I ran into was that since I had a Boolean constraint, I was not able to run a sensitivity analysis graph. Manual data entry, imported data entry, I was able to get both of those done. So there's two different ways that you can put data into the system. And also I was able to report on my findings and let the user see the production plan and also the final optimal costs. One of the challenges was importing data. It was difficult to find a method to get from one workbook to another, but that was something I was able to do. The variable time period was also something that was difficult to do for the sheer fact that whatever the user put, I had already had 20 slots in the economic lot sizing workbook with functions in them. If I created them every time, I would have to recreate the functions, which I could never find a way to do. Creating a sensitivity analysis was another challenge, like I said before, due to the Boolean variable that was one of my constraints. The visual basic coding was tough. Understanding the linear programming model and also implementing dynamic programming model, simply because of time constraints. So for future research, I hope to look into the dynamic programming more, definitely debugging the current system, and other areas of MRP. Like I said before, my project 2 was also in MRP, so right now I have 2 parts of it down. Thank you so much.